Alright folks, let's look at another math notes here. We are on 8.3.1 and today we're going to be talking about the fundamental theorem of algebra. So the fundamental theorem of algebra essentially states that every polynomial in one variable has at least one complex root and that the number of roots equals the degree of the polynomial. Let's see what that means and what we're talking about here. So basically, for a long time, we've called a quadratic expression factorable if it could be written as the product of two linear polynomials with integer coefficients. Another way to think about that is if we did the area model and diamond problem, if we could solve those with integers, then we said it was factorable. And if we couldn't, and there wasn't any way to satisfy the diamond problem or fill in the area model, then we would say it was not factorable. But if we allow ourselves to use fractional, irrational, or complex coefficients, then we can write any polynomial in factored form. And we got into fractional and irrational coefficients once we started doing the quadratic formula and completing the square. And then the last type that we talked about were complex coefficients, where you had imaginary numbers when you did completing the square or the quadratic formula. So they have some examples here for you. So they say if p of x equals x squared minus 2, that can be written in factored form as x plus or minus the square root of 2. We could solve that real fast if we had x squared minus 2 equals 0. We added 2 to each side, we get x squared equals 2. Then we took the square root, we would get x equals plus or minus the square root of 2. Therefore, in factored form, since those are our two roots, then we could say that p of x equals x plus root 2 times x minus root 2, which is what they have here. In their next example, if you have p of x equals x squared plus 4, well, what you should see is that if we subtract 4 from each side, then we're going to end up with a negative number. We're going to have to take the square root of that negative number. So our x squared plus 4 equals 0 becomes x squared equals negative 4. And once we take the square root of a negative, then we have to introduce I. So this is going to equal plus or minus 2i. So in factored form, that's going to look like this: x plus 2i and x minus 2i. So in the blue we have irrational factors, and in the red we have complex factors. So once we allow ourselves irrational numbers and complex numbers, then every polynomial can be factored and such that it has the same number of factors as it does the degree of the polynomial. That's not to say that they will all be unique roots. Some of them might be double roots and some of them might be triple roots, etc., etc. So if we look in this case, in some cases a factor may be repeated. For example, x cubed minus 5x squared plus 8x minus 4 is factored into x minus 2 times x minus 2 times x minus 1, or x minus 2 squared times x minus 1, in which case we get a double root here because we have that square, or we have this factor repeating itself twice. Similarly, if you took this fourth degree polynomial down here, it ends up with a triple root of x plus 1 cubed minus x minus 3. So we still have 4 roots for the fourth degree polynomial. It just requires that that be repeated 3 times. Okay, that's about it for this one, guys. Make sure you write down the important stuff and have it ready for class.